This is section 4.5, which is over graphs of sine and cosine functions. It's pretty important that you are able to get a handle on graphing these two functions rather quickly, because in the next unit you will need to know how to graph sine and cosine in order to graph some of the other trig functions. Just like any other function, we will have parent functions, and y equals sine of x and y equals cosine of x are going to be your parent functions. Then what we're going to do is we are going to manipulate them in different ways and see how they behave. So let's start with sine of x. So if I were to graph y equals sine of x, here I've provided a chart which includes values found on our unit circle. So these are the values on our unit circle. When I plug them in, or these are our angle measures rather, when I plug them into sine, we get this row of outputs. So basically, each of these represents an ordered pair. And if I graph each of those points, I end up with this curve here, which is often referred to as the sine wave. Now, there are lots of different things I'd like to point out about this graph. So let's just start with this line here, the x-axis in this case. When graphing these, I often refer to this as the baseline. And you will see in the sine curve, this is one revolution around the unit circle. And one revolution around this unit circle in this case is known as a period. And the period of the sine curve is 2 pi. So that's one full cycle. Once you get to 2 pi, this curve will continue. So it continues to the right forever. Likewise, it will continue to the left forever. The sine curve starts and ends on the baseline, and halfway in between, it is also on the baseline. Then, 1/4 of the way, it is at its maximum, and 3/4 of the way, it is at its minimum. The sine function, as mentioned before, has a period of 2 pi. And basically, this means that one full cycle is in between 0 and 2 pi, and then the curve goes infinitely to the right and to the left. Cosine can be found in a very similar way. So again, these are values from the unit circle. If I plug these angle measures into cosine, I get these outputs. And again, each of these represents an ordered pair. So if I were to graph this function, this is basically like a giant T-chart. And when I graph this, I end up with the following curve. Again, one full cycle or one period occurs in 2 pi units. And again, we have our baseline. Now the difference here is that on our cosine graph, you will notice that we start and end at the maximum. Halfway, so this is the max and this is the max. Halfway between, we are at a minimum. And then 1/4 of the way and 3/4 of the way, we are on the baseline. Similar to the sine function, there is a period of 2 pi for cosine. which means that an entire cycle will occur between 0 and 2 pi, but once again, the cosine graph does extend forever to the right and forever to the left. So some things that we would like to mention is basically comparing sine and cosine. If you look at this, sine is in blue, cosine is in red. They both extend forever to the right and forever to the left. And here we're showing you 2 revolutions of each of them, or 2 periods, or 2 cycles. So we have one negative cycle and one positive cycle. And you can see the difference between the two. The blue function, or sine, starts and ends on the baseline, whereas the red function, or cosine, starts and ends at its maximum. On this slide, we discuss several different characteristics of the 2 trig functions. And a lot of them are very similar. So first, we're talking about the domain. The domain of both of these is negative infinity to infinity because they both extend forever left and forever right. The range of each of these functions is in between -1 and 1. Both of these are sandwiched in between these 2 values here. And again, the period is 2 pi. Some things to mention: sine of x is symmetric with respect to the origin. Therefore, it is an odd function. On the other hand, cosine of x is symmetric with respect to the y-axis and therefore is an even function. You may recall information regarding even and odd functions. If that's something you forgot about, you might want to do a quick Google search on that. And then finally, sine and cosine simply differ by a horizontal shift of pi over 2. So if I shift the cosine graph left pi over 2 units, then it becomes a sine graph, really. The graphs are different in terms of their maximums and minimums, as well as their x-intercepts. And sometimes when we graph these, it's helpful to identify the quarters of the period, and that will help us identify key points on the graph. Okay, so here I've already talked about it, so I'm not going to spend a whole lot of time on this slide, but again, the graph of y equals sine of x. Again, we call this, or I call this, the baseline. And you can see that the sine graph starts and ends on the baseline. Halfway in between, it is also on the baseline. 1/4 of the way, a quarter of the period, it is at its maximum, and 3/4 of the way, it is at its minimum. The graph of cosine of x, again, we've talked about this. This is the baseline. And depending on how we alter this equation, the baseline can shift up or down. And we'll get to that shortly. But as mentioned previously, when graphing cosine, we start and end at the graph's maximum values. Halfway between, we are at the graph's minimum, and then 1/4 of the way, a fourth of the period, 1/4 of the way and 3/4 of the way, we are on the baseline. Now we're going to add a little something to these equations that's going to alter our graph a little bit. And that is attaching some number or multiplying some number by sine or cosine. And what this is going to do is this is going to stretch or shrink our graph vertically. One other thing that may happen is if A is negative, then we will have a reflection across the x-axis. This value, A, is referred to as the graph's amplitude. The amplitude is basically the distance between the baseline. So if this is sine, the amplitude is the distance from the baseline to the maximum or the baseline to the minimum, and that's the same value. So it represents half of the distance between the maximum and the minimum. So if this is the entire distance, the max and the min, halfway in between the two, that will help us identify the amplitude. So let's talk about the amplitude. And again, when we're dealing with the amplitude, if you look at this first example, there's a negative sign. That negative sign just tells us that we are reflecting across the x-axis. So we don't consider that negative when dealing with the amplitude. The amplitude is the absolute value of A. And in this case, A is -8. The absolute value of that is 8. So that means when I graph this, the distance from the baseline to the maximum is 8 units, and the distance from the baseline to the minimum is 8 units. So this is going to be a vertical stretch because the graph is going to be getting skinnier. But this doesn't account for the reflection. Okay, here in number 2, the amplitude is the absolute value of 2/3, which is 2/3 in this case. Not so bad. So this case, our graph is going to be flatter. So let's take a look at how we would sketch a graph of this. Now, when you see this graph, when you see cosine, I want you to think that the graph is going to start and end at its maximum, and halfway between it's at its minimum. It's also helpful to identify the amplitude, and we did this in the previous problem. The amplitude is 2/3. So the distance between the baseline and the maximum and the baseline and the minimum will be 2/3. Since this value is less than 1, this is going to be a vertical shrink because it's less than 1. Okay, so if I were to sketch a little picture of this or sketch a graph of this, then here's basically how I start this. I'm going to graph one period, and one period is between 0 and 2 pi. Then I split this in half. Half of 2 pi is pi. Then I split that in half, and that is pi over 4. So I'm going to think of, pi over 2. Then I'm going to think of these half units. So if this is pi over 2, this is 2 pi over 2, this is 3 pi over 2, and this is 4 pi over 2. Now, typically our range is between -1 and 1, but my amplitude is 2/3, which means I'm going to start and end at the maximum, which is 2/3. Then I'm going to be at my minimum halfway between 1/4 and 3/4 of the way. I am at my baseline. So the graph is going to look like this. Here I've graphed for you what what cosine of x looks like. So this dashed line is cosine of x. And then the blue line here is 2/3. So this one is 2/3 cosine of x. And you can see that we do have a vertical shrink. We are taking this and shrinking it vertically. Okay, let's take a look at another example. Now we are graphing sine, so hopefully you think that the graph starts and ends on the baseline, halfway between it's on the baseline as well. Looking at this, the amplitude is 2 because the absolute value of -2 is 2. And this negative sign is important. This tells us that we are going to reflect across the x-axis. All this means when graphing the sine function is that the maximum becomes the minimum and the minimum becomes the maximum. So let's take a look at this. If I were to sketch this, again, we will graph one period, which is between 0 and 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. My amplitude is 2, so I'm still going to start and end on my baseline, halfway in between. But now, because I'm reflecting across the x-axis, instead of a maximum up here, I'm going to make a minimum first and then the maximum second because we are just reflecting that. And here is a comparison again. The dashed line is the graph of sine of x, and the blue line is the graph of -2 sine of x. So you can see that we have a vertical stretch. We have a vertical stretch because 2 is greater than 1. Okay, so it's kind of nice to see this comparison here. On the next slide here, I'd like you to pause the video and go ahead and attempt to graph these two functions on your own. Okay, so when we graph this, this is a graph of cosine, and it has an amplitude of 2. So graphing this, you should end up with the following. When you graph cosine, you start and end at your maximum, halfway between at a minimum, and 1/4 and 3/4 of the way at the baseline. Over here in part B, this is a graph of sine of x. We will have a reflection. And since we are multiplying by 1/3, this graph will be a bit smushed. So here we go. Here is 1 and -1. So when I graph this, since this is a sine curve, we will start and end on the baseline halfway between. But because of our reflection, we are going to have a minimum first and then a maximum at 1/3 because the amplitude is 1/3. So our curve looks like this. Okay, so hopefully you have the reflection and the amplitude down, because now we are going to apply something else. Now we're going to multiply the argument of x by something. This is going to give us a horizontal stretch or shrink. And it will also affect the period of the graph. So if you think about this, think about a slinky and holding it sideways or an accordion. And when you pull and compress, that will alter the slinky or accordion. That'll affect its horizontal shape. That's what this value of B is going to do to the graph. So here, if you look at this, we have two graphs. The dashed line is the graph of sine of x. So it's just your basic parent graph. But then if I multiply that argument of x by 2, what I'm doing is I'm taking this graph and I'm smushing it so that a full revolution or a full cycle happens in between 0 and pi. So basically, I have 2 cycles now instead of the 1. Take a look at this one. Here, again, in the black is the parent function, but in the red, now I'm multiplying by a factor of 1/2. So now what I'm doing is I'm stretching this out. So in the normal parent function, there are 2 cycles in between 0 and 4 pi, but now in the red graph, we have just 1 cycle in between 0 and 4 pi. So here, this is a horizontal stretch. In the previous graph, that was a horizontal shrink. So we can see that the period is being affected by this value of B. In fact, anytime we want to find the period of a graph, what we can do, and you may have noticed this pattern, is we take the period of the parent function, which is 2 pi, and we divide it by B. And again, B is whatever is being multiplied by x. So in this case, 2 pi divided by 1/2 is in fact 4 pi. And that's where the period comes from. I think this slide is a bit helpful because it tells us how to find one complete cycle of the graph. And it will become more helpful when we have more items involved in our equation. But basically, to find one complete cycle, what I'll do is I'll sandwich this in between the interval 0 and 2 pi, because that's your basic period for your parent function, and then solve for x. And then this will tell you where the cycle starts and where the cycle ends. And we'll see this again in the future. And we already talked about this. The period is equal to 2 pi divided by b. So a couple things to mention. Sometimes when we are graphing trig functions, this multiplier in here is negative, and I just want to remind you of what happens with odd functions and even functions. If the argument is negative here, the output is negative, and this is because sine is an odd function. And if this input is negative, the output is positive, and this is because cosine is an even function. Sometimes this comes up. It doesn't happen that often, but I'll show you an example in the next slide. Okay, so here it says graph this function over one full period and identify the amplitude in the period. So When looking at this, the amplitude should be pretty straightforward. The amplitude is 2. Remember, to find the period, we take 2 pi divided by b, and in this case, b is 4. Let me address, sorry, because this here is an even function, these two are equal. Okay, so this input becomes positive here. Okay, so we're going to divide by 4 in the period, and so the period is pi over 2. This means that one complete cycle will happen between 0 and pi over 2. So it might be helpful to break this up into fourths. So if I were to sketch a picture of this graph, I'll just show this. So if I were to sketch this graph, I know that I'm going to start at 0 and end at pi over 2. And then halfway between is pi over 4. That will be the minimum since this is the graph of cosine. And then half of a fourth, half of a fourth, of means multiply, is pi over 8. So you can think of this as pi over 8 intervals. This is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, and then reduce it as needed. Let's give this one a try. Looking at this, 2 is the amplitude. If I want to find the period, I use b. So the period is 2 pi divided by b. In this case, it's pi divided by 2 once again. So we can use that little interval I was showing you a few slides ago and sandwich the argument in between 0 and 2 pi, and then solve for x. And the way we'll solve for x is dividing everything by 4. So 0 is less than or equal to x is less than or equal to pi over 2. This means that one full cycle will occur between 0 and pi over 2. So let's go ahead and sketch one full period of this. So, and I'm just going to spread this out a little bit. Typically this is 2 pi, so this is pi, and this is pi over 2. But I would have to graph the entire graph in this region, which is going to get super messy. So what I'm going to do is I'm just going to stretch this out just for viewing purposes. And I'm going to call this pi over 2. Half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Then graphing this is the graph of sine, so we will start and end on the baseline halfway between. Let's see, and then the amplitude is 2. There isn't a reflection, so our maximum is here and the minimum is here. So here is a sketch of this curve. I think it's time now to add on a little bit more to these graphs. Basically now what we're going to do is we are going to have horizontal and vertical shifts. C is going to shift the graph horizontally, where D is going to shift the graph vertically. So let's analyze this a little bit. Now that we are going to shift the graph horizontally, this is called a phase shift. So what we're going to do is we're going to pick up that entire cycle and shift it to the right or shift it to the left. So the whole function is going to be moved. And what we can do the same way as we did before, we are going to sandwich the argument, which is now all of this, in between 0 and 2 pi. And then we're going to solve for x just like before. And now this is helpful because we're not going to be starting at an x value of 0 anymore. Now we can be starting to the right of 0 or to the left of 0, and we can figure out where our starting point is and where our ending point is. So let's see this in action. So there's a lot we need to discuss here on this. There's a lot going on. So looking at this, first of all, notice it's a sine curve. We will want to identify the amplitude. The amplitude is 3. We'll want to find the period. The period, again, is 2 pi divided by b, and b is 2. So the period is pi, which means one full cycle will take place over pi units. But those pi units can be shifted one way or another. In fact, this here tells us that we will have a phase shift, and we will need to identify what that is. So looking at this, let's sandwich our argument in between 0 and 2 pi. Our argument here is 2x minus pi over 4. Remember, the argument of the trig function is whatever's in parentheses. So we're just going to solve this. To solve this, I'm going to add pi over 4 to both sides. So we have pi over 4 is less than or equal to 2x is less than or equal to. Over here, remember this can be written as 8 pi over 4. That's equivalent to 2 pi. So 8 pi over 4 plus pi over 4 is 9 pi over 4. And then we're going to divide by 2. And when I divide everything by 2, that's the same as multiplying by a half. So we end up with pi over 8 is less than or equal to x is less than or equal to 9 pi over 8. So I'm going to have a phase shift. I'm going to start at pi over 8, and I'm going to end at 9 pi over 8. And if you subtract these two values, you will see that you will get pi, and that's the period. So here is what we have. So let's see. So here, this second graph down here, this is just the graph without the phase shift. So you can see it starts at 0. But now, this is the graph of the actual function here. You can see that cosine actually starts at pi over 8 and ends at 9 pi over 8. You may want to see where the halfway point is, and the way you can find the halfway point is average those two. So if you take 9 pi over 8 plus pi over 8 and divide by 2, you will end up getting the halfway point. Okay, so let's do one of these in full. Okay, so just like before, we want to find the amplitude and the period. Because I don't have anything in front of cosine, that's like a 1 there. So the amplitude is 1. The period, again, is 2 pi divided by b, and b is 3 in this case. So it's helpful to figure out where this graph is going to start and end. So we'll sandwich the argument, which is this, between 0 and 2 pi. So to solve this, I will add pi over 2 to all sides. So I have, let's see, pi over 2 is less than or equal to 3x is less than or equal to, again over here we will get 5 pi over 2. In this case, think of 2 pi as 4 pi over 2. 4 pi over 2 plus pi over 2 is 5 pi over 2. Then I'll divide everything by 3, which is the same thing as multiplying by a third. So pi over 6 is less than or equal to x is less than or equal to 5 pi over 6. So when I graph this, we're going to start at pi over 6 and end at 5 pi over 6. So you can kind of think of it that way. So if this is pi over 6 and this is 5 pi over 6, you're going to want to figure out what the halfway point is. So it's basically the average of the two. So if you average this, you will end up with pi over 2. And let me just show you. So if you take pi over 6 plus 5 pi over 6 and divide it by 2, it's the average. You get 6 pi over 6 in the top divided by 2. Well, 6 pi over 6 cancels to just pi, and so pi over 2. So this is pi over 2. Then you need to figure out the average there. Well, this is pi over 3. Think of it this way. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and just reduce the fractions when necessary. Okay, so here's my intervals. My amplitude is 1, and this is cosine. So I'm going to start and end a maximum, halfway between the minimum, and then 1/4 and 3/4 of the way on the baseline. And there you have it. Finally, the last thing that we're going to add to the equation is the vertical shift. This will either shift the graph up if D is positive or down if D is negative. Basically, this will just move the baseline. So let's take a look at what happens here. So putting this all together, there's a lot going on. So the amplitude is 3. The period is pi. This tells us that we have a vertical shift of 2 units. And then we'll also want to identify if we have a phase shift at all. So the way we identify if we have a phase shift is we can tell there's something going on, but let's go ahead and sandwich things. So 0 is less than or equal to 2x minus pi over 4 is less than or equal to 2 pi. I'm just going to wave my hands a little bit and save you some time and tell you that this becomes the following. Since this is where we are going to start, this tells me that I have a phase shift of pi over 8 units, or I'm shifting the graph right pi over 8. And here's what this graph looks like, and I want to show you. Because I have a vertical shift of 2 units, that means this baseline is moving up 2 units. So here is my new baseline. I'm going to start and end at my max. Since it's sine, I'm going to start and end on my baseline. I'm going to start at pi over 8 and I'm going to end at 9 pi over 8. So you can think of this in scale or pi over 8 units. This is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, so on and so forth. I think you get the gist. So you're going to want to find the middle, which is the average. That is 5 pi over 8. And then the maximum is 3 units from the baseline and up and then down. Okay, so here is the graph. I would recommend you pause the video and give this one a try. Okay, so the amplitude is 2. The period is 2 pi over 3. We have a vertical shift of 3, so it's going up 3 units, and that's determined by D here. I have a phase shift of pi over 3. So again, you can sandwich the argument. And when you do, waving my hands, you end up with pi over 3 is less than or equal to x is less than or equal to pi. So one full cycle is going to occur in between pi over 3 and pi. So when I graph this, let's say this is 2 pi. So half of that is pi. Half of that is pi over 2. Okay, well, here we're going to need to be a little bit careful because we're starting at pi over 3. So if we're starting at pi over 3, we need to keep breaking this interval down. So let's do this. Now, pi over 2 will be helpful shortly, but we know we're going to start at pi over 3. So let's call this pi over 3. So if this is pi over 3, then we're going to start at pi over 3, and we're going to end at pi. So we need to figure out the halfway point. And the halfway point is actually 2 pi over 3. So if you think of this as, let's see, so this distance is pi over 6. So pi over 6, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 7 pi over 6, 8 pi over 6, so on and so forth. That might be one way to look at it. Then the minimum is, oh, sorry, the baseline moves up. Let's see. Up 3. So our baseline is now here. Our amplitude is 2, so this is really 5. So from our baseline to our maximum is 2 units, 2 units down here, here, and here. And there you have it. Here, this page just summarizes everything, talks about all of the different characteristics. There's really not a lot on here that we haven't talked about. This just sums it all up. Okay. So we will see applications of these graphs, of these functions. And they're referred to as sinusoidal behavior because they take on the shape or the direction of a sine or cosine graph. So basically, here is an example. It's talking about high and low temperature over the course of a year. And what we're going to do is we are going to come up with an equation that represents this curve. So we can see that this curve represents or looks similar to a sine wave. So what we're going to do is we're going to write an equation for it. Okay, so here is basically the formula, if you will, that we will use. H of t represents the temperature, and t represents the month. So looking at this, we're going to need to come up with a value for A, B, C, and D. Okay, now let's talk about, first of all, there's a reflection. You can see that this graph starts and ends at the minimum. So we know that it's going to be reflected across the x-axis. Oops, reflected across x-axis. So that means A is going to be negative. Okay. We will want to identify the amplitude. Now, looking at this graph, it's kind of hard to see where the new baseline is, and that might be helpful to find out shortly. But we do know the high and low temperature. And if I take the high temperature minus the low temperature and divide by 2, I'll find that middle ground. So it's going to be the high temperature minus the low temperature. Half of that will give me my amplitude. Okay, so the high from the previous slide or from this graph is 80, minus the low is 32 degrees, and divide by 2. This is 48 divided by 2, which is 24. Okay, so our amplitude is 24, which means I'm going to be plugging in a negative 24 here. Okay. The period is the length of an entire cycle. And we know that this full cycle is 1 year or 12 months. So with that being said, if the period is 12, then I know that 2 pi divided by b is equal to 12. If I solve this for b, I will find that b is equal to pi over 6, which means I know this value here is pi over 6. We can see that this graph is starting at 0, so we don't move right or left at all. So C is equal to 0, so we won't have anything there. And then finally, we're going to want to identify the vertical shift. So we want to figure out how many units upward this graph traveled. And there are a couple ways you can do this, but one thing you can think of for the vertical shift is you can take the high value plus the low value and divide by 2. And this will give you the halfway point. When you do this, you have 80 plus 32 divided by 2. This gives you 56. So D is 56. And then we can put this all together to come up with our equation. And our equation is H of t is equal to negative 24 cosine of pi divided by 6t I don't have a value for c, so that's that is it for the argument, plus 56. There's one last example I want to show you. Go ahead and pause this and read through it real quick. What you will find is that the pendulum moves 3 inches to the left and to the right of the center position. So this is a little bit different, but we know it's moving right and left 3 units. This actually tells us that the amplitude is 3. It goes on to say that it returns to the starting position in a time of 0.8 seconds. So that tells us that the length of a period is 8 seconds. So the period, or 2 pi divided by b, is equal to 0.8. If I solve this for b, b is equal to 5/2. I know A, I know B. This isn't starting at any goofy place, so there isn't a phase shift or a vertical shift. So I can go ahead and write my equation. X of t is equal to 3 cosine of 5/2 t. And this concludes the lesson for section 4-5.